Hello students. So this video is on module 5 RTOS and IDE for embedded system design. This is a continuation part of module 5. So this is a lecture 3. In this video I'm concentrating on the topic task communication. In that I'm going to cover topics on shared memory and message passing. Let us understand about task communication. So in multitasking systems, multiple tasks and processes which are running simultaneously, and process may or may not they interact with each other. Based on the degree of the interaction of the process or any tasks, the process running on an OS are classified as cooperating processes, competing processes. So cooperating processes means one process requires the input from the other process to complete its execution is nothing but cooperating processes. So in competing process, the processes do not share anything among themselves, but they share only system resources. In competing process, they compete for the system resources such as file, display devices, etc. Cooperating processes exchanges information and communicate through the following methods like cooperation through sharing and cooperation through communication. The cooperation through sharing, where the process will exchange data through some shared resources. While cooperation through communication, there no data is shared between the processes, but they communicate for synchronization. The mechanism through which process or any task communicate each other is known as inter-process or task communication, IPC. Inter-process communication is essential for process coordination. So here we require coordination between the processes. So that is done through this, or the mechanism through which the communication takes place between the process or any task is known as this IPC. The various types of inter-process communication mechanism adopted by process are kernel dependent. Some of the important IPC mechanism adopted by various kernels are shared memory, message passing, remote procedure call, and sockets. So we'll discuss each type of this or mechanism in detail. Shared memory. Processes share their some area of the memory for this communication among the different processes. The information which is to be communicated by the process is written to this shared memory area. That is what it is shown in the diagram. The other processes which require this information, they can also read the same from this shared memory area. It is something like the example what I can give you in a real world example is a notice board. So in this notice board, which is used by the corporate to publish the public information among the employees. The only exception for this is only corporate have the right to modify the information which is published on the notice board, and the employees are given only to read. Only they can assess the message, meaning that it is only a one-way channel. This implementation of this shared memory concept is nothing but a kernel dependent. Different types of mechanism are adopted by different kernels for implementing the concept of this shared memory. Like we have pipes, memory mapped objects. So we'll discuss about in detail about this. Pipes. Pipe is nothing but a section of a shared memory which is used by processes for communicating. Pipes follow the client server architecture. A process which creates a pipe is known as a pipe server, and a process which connects to a pipe is known as a pipe client. A pipe can be in real world whatever the pipe we used, which is as a channel for flow of water or any other fluids what we use, the same way here also we can relate the pipe with the real world pipe. So this pipe also has which is used for the flow of information, and it also has conceptual two ends. Pipes can be unidirectional or bidirectional. Unidirectional means it allows information flow in one direction. Bidirectional allows bidirectional information flow. A unidirectional pipe allows the process connecting at one end of the pipe to write to the pipe, and the process connected to the other end of the pipe to read the data. Whereas in bidirectional pipe, it allows both reading and writing at one end. So the figure below here shows a unidirectional pipe. The implementation of pipes is also OS dependent. Microsoft Windows desktop operating systems support two types of pipes for inter-process communication. They are anonymous pipes and named pipes. Anonymous pipes are unnamed. They are unidirectional pipes, and they are used for data transfer between two processes. While named pipes is a named, and they are unidirectional, or it might be a bidirectional pipe for data exchange between the processes. Like anonymous pipes, the process which creates the named pipe is known as pipe server, and the process which connects to the named pipe is known as pipe client. With named pipes, any process can act as both client and server, which allows point-to-point communication. Named pipes can be used for communicating between processes running on the same machine or processes running on different machines for connecting to a network. Memory mapped objects. Memory mapped objects is nothing but a shared memory technique adopted by certain real-time operating system. They are used for allocating a shared block of memory which can be accessed by multiple processes simultaneously. So in this approach, a memory map object is created and physical storage for it is reserved and it is committed. A process can map the entire committed physical area or a block of it to its virtual address space. All read and write operation to this virtual address space by a process is directed to its committed physical area. Any process which wants to share the data with other processes can map the physical memory area of the mapped object to its virtual memory space, and it can use for sharing the data. Message passing. Message passing, we can say that as an asynchronous or synchronous information exchange mechanism which is used for inter-process or thread communication. The major difference between this shared memory and this message passing technique is that through shared memory, lot of data can be shared, whereas only limited amount of information or data is passed through in this message passing. Also, message passing is relatively fast and free from synchronization overheads compared to shared memory. Based on the message passing operation between the processes, message passing is classified into message queue, mailbox, signaling. Message queue. Usually, any process which wants to talk to another process, it posts the message to first in first out queue, which is called as message queue, which stores this message temporarily in a system which is defined in memory as memory object to pass it to the desired process. Usually the process which wants to talk to another process posts the message to a message queue. Messages are sent and received through send and receive methods. Send means name of the process to which the message to be sent. Receive, the name of the process from which the message is to be received. This implementation of message queue, send and receive methods are OS kernel dependent. This figure shows the messages are sent and received through send and receive methods. The Windows XP OS kernel maintains a single system message queue and one process or thread specific message queue. A thread which wants to communicate with another thread posts the message to the system message queue. So if any thread wants to communicate with another thread, it just posts the message to the message queue that it wants to communicate with each other. Then the kernel will pick up this message from the system message queue one at a time, and it examines the message for finding the destination thread, to which thread the communication or the message has to be passed. Everything will be examined by the kernel, and then it posts the message to the message queue of the corresponding thread. The messaging mechanism is classified into asynchronous and synchronous based on the behavior of the message posting thread. In asynchronous messaging, the message posted by the thread, just it posts the message to the queue and it will not wait for the acceptance from the thread to which the message is posted. In synchronous messaging, the thread once which posts the message enters waiting state and it waits for the message result from the thread to which the message is posted. The thread which invoked the send message becomes blocked and scheduler will not pick it up for scheduling. Mailbox. Mailbox is an alternate form of message queue and it is used in RTOS for inter-process communication, usually for one-way messaging. This task or thread which wants to send a message to another task or any threads, it creates a mailbox for posting the messages. The threads which are interested in receiving this message, it posts to the mailbox by mailbox creator thread can subscribe to the mailbox. The thread which creates the mailbox is known as mailbox server, and the thread which are subscribed to the mailbox are known as mailbox clients. This mailbox server which posts the messages to the mailbox and it notifies it to the clients which are subscribed to the mailbox. These clients read the messages from the mailbox on receiving the notification. Here this diagram shows the concept of mailbox. Here task 1 wants to send the message or it wants to post the message. Then task 1 has to create the mailbox. So once the mailbox is created, if that message has to be read by any other task, means for example here task 2, task 3 and task 4 we have. So these 3 tasks want to read the message which is sent from the task 1 has to read the message from the mailbox. Then it has to, these tasks 2, 3 and 4 has to subscribe for the mailbox to read the messages. So once the subscribe is done, they will receive the messages. So here task 1 is known as mailbox server and task 2, 3 and 4 are known as mailbox clients. The mailbox creation, subscription, message reading and writing, these are all achieved through OS kernel, which is provided by API calls, that is application program interface calls. So mailbox and message queues are same in functionality. The only difference between them is the number of messages which are supported by them. Both of them are used for passing the data in the form of messages from the task to another task. Mailbox is mainly used for exchanging a single message between two tasks or between an interrupt service routine and a task. Mailbox associates a pointer pointing to the mailbox and a wait list to hold the tasks waiting for a message to appear in the mailbox. Signaling. Signaling is a primitive way, that is a relating way of communication between processes and threads. Signals are used for asynchronous notifications, where one process or thread fires a signal indicating the occurrence of a scenario which the other processes or threads is waiting. Signals are not queued and they do not carry any data. That means queuing of signals is not allowed and they don't carry any of the datas. For example, in communication mechanisms, which is used in RTX 51 TinyOS, inter-process communication in VxWorks OS kernel are the examples of signaling. Remote procedure call RPC and sockets. Remote procedure call RPC is the inter-process communication IPC mechanism which is used by a process to call a procedure of another process which is running on a same CPU, or it might be in a different CPU which is interconnected in a network. In the object-oriented language terminology, RPC is also known as remote invocation or remote method invocation, RMI. RPC is mainly used for distributed applications like client-server applications. With RPC, it is possible to communicate over heterogeneous network. That means any network where client and server applications are running on a different OS. The CPU or process containing the procedure which needs to be invoked remotely is known as server. The CPU or any process which initiates an RPC request is known as a client. Here this diagram shows the concept of a remote procedure call. In the first diagram we can see that the processes which is running on a different CPU which are to be networked, and the next diagram, that is figure 2, shows the processes which are running on a same CPU. It is possible to implement remote procedure call communication with different invocation interfaces. Interface definition language IDL defines the interfaces for this RPC. The RPC communication can be either synchronous or asynchronous. Synchronous we also call it as blocking, asynchronous as non-blocking. In synchronous communication, the process which calls the remote procedure is blocked until it receives a response back from the other processes. While in asynchronous RPC calls, the calling process continues its execution while the remote process performs the execution of the procedure. The result from the remote procedure is written back to the caller through mechanisms like callback functions. On security front, remote procedure calls employs authentication mechanism to protect the system against vulnerabilities. That means possibility of being harmed. The client applications should be authenticate themselves with the server for getting any access. Authentication mechanisms like any IDs, public key, cryptographies, etc. are used by the client for authentication. Without authentication, any client can access the remote procedure. This method may lead to potential security risk. Sockets are used for this remote procedure call communication. Socket is nothing but a logical endpoint in a two-way communication link between two applications which are running on a network. A port number is associated with a socket so that network layer of a communication channel can deliver the data to the designated application. Sockets are of different types, namely internet sockets, Unix sockets, etc. The internet sockets works on internet communication protocol. The TCP/IP, UDP, etc. are the communication protocols used by internet sockets. Internet sockets are classified into two types: stream sockets, datagram sockets. Stream sockets, these are connections oriented, and they use TCP to establish a reliable connection. While this datagram sockets, they rely on UDP for establishing a communication. The UDP connection is unreliable when compared to TCP. The client-server communication model uses a socket at a client side and a socket at the server side. A port number is assigned to both of these sockets. The client and server should be aware of the port number which is associated with the socket. In order to start the communication, the client needs to send a connection request to the server at a specified port number. The client should be aware of the name of the server along with its port number. The server always listens to the specified port number on the network. Upon receiving a connection request from the client, based on the success of authentication, the server grants the connection request and communication channel is established between the client and the server. The client uses the host name and port number of the server for sending requests, and server uses client's name and port number for sending responses. If the client and server applications, both the processes are running on same CPU, both can use the same host name and port number for communication. The physical communication link between the client and the server uses network interfaces like Ethernet or Wi-Fi for data communication. This underlying implementation of socket is OS kernel dependent. Different types of OS provide different socket interfaces. These are the two books referred for these topics.